Anyway, what is DQMH? So DQMH, it stands for Delacorte Queued Message Handler. It's a LabVIEW tool. It's 100% free. You can download it from VI Package Manager. DQMH it's a framework for LabVIEW, created by Fabiola and her team at Delacorte. By framework, I mean that it's like a foundation on which LabVIEW developers can use to get a leg up in building an application that takes advantage of a lot of good LabVIEW programming practices. So sort of the things I was just covering before in the last slide, those sorts of things. The DQMH tools come in the form of some scripting tools that essentially allow you to auto-create your application building blocks. So you can create code modules, you can create events, which we use to communicate between the modules, and you also, out of the box, get an API tester. Now, to demo this, I'm going to bring up a project, not that one. Let's bring up another one. So if you've already installed DQMH through the VI Package Manager, just jump into Tools, Delacorte, DQMH module, add new DQMH module. That's sort of the first thing you do with DQMH. We fire that up. And here we go about creating our DQMH module. We give it a name, we give it a path, we decide whether the module type is singleton or clonable. Singleton, as the description says, is a singleton module only ever exists as a single instance. A clonable can have multiple re-entrant instances running simultaneously. We can create an overlay. I'm not going to hit OK, but you would hit OK. It takes a minute or so. My computer's pretty slow, so I'm not going to do that. I'm going to cancel that and show you one I prepared earlier. So this is what it would have created. Out of the box, you get a LabVIEW library. That's our module. At the top of the tree of that LabVIEW library is main.vi. Every DQMH module gets created has a main.vi. That's our top level VI. You also get a tester for your module. And that's, in a nutshell, what happens when you create a DQMH module. The module, if we open up main.vi, looks like this. It's runnable code out of the box. It's a queued message handler design pattern. We have an event handling loop and a message handling loop. Our event handling loop handles user events, and our message handling loop processes those. So, like I said before, if you start with a DQMH module, we're getting built into our module straight out of the box a whole lot of good programming practices. We're building on the shoulders of giants. So that's a module. What's an event? A DQMH event. We go to Delacorte, DQMH event, create new DQMH event. And you get this dialog pop up. And we can go in and we can create a new event. Events are what make our module specific to an application. They're a way to call our module to action, request it to do something, or request data from it. Or the module can generate its own events, which is a broadcast, and it can share that with other applications that are using this module. The event types, there's 4 there: request, broadcast, request and wait for reply, or round trip. I'm not going to go into each one of those in detail now. So in terms of, so that's our events. The third main important part, I think, is the API tester. And let's just cancel this event generation for now. The last thing I was going to say with the events is when you create an event, it will go in and automatically update your existing code. It will go in and add a new event to our event handling loop. It'll go and add a new use case to my message handling loop. And it will also go to our tester and update the tester. But out of the box, this is what the tester looks like. It's pretty simple. Welcome, newcomers. This is our tester. It's pretty basic. What we have here, we have buttons to be able to generate, or to be able to call the events that come with your DQMH module out of the box. So these ones here, show module panel, hide module panel, they're out of the box. You get those by default. As I said before, as we add new events, we get a new button added to our tester. So there's a lot of automated scripting going on. You still have to obviously go and write your code to make it do what you want it to do, but the framework allows you to build the tool in a scalable way. Just another point, the public API folder in our DQMH module, that's where all the events live, right? So as we add new events, we'll see them appear here in our requests folder. You might notice as well, there's a number of different folders here, virtual folders. And don't be daunted by that. There is a lot going on under the hood, but it works, trust me. And I think if you're getting familiar with it, just trust in it and roll with it and learn it over time. Don't feel that you have to understand every single VI that's going on under there. I still don't. So what do I need to use DQMH? Jump into VI Package Manager, search for Delacorp, download the Delacorp QMH and the associated dependencies. How do I learn it? My recommendation is just jump straight to the Delacorp website there and click on the How to Learn DQMH. And there's some good suggestions about where to go from there. All right, so that is DQMH in a nutshell. I hope I did it justice, Fab. So anyway, getting on to topic. So the topic, thanks. 8 reasons for encapsulating your next device driver in DQMH module. So to help me demonstrate what I'm going to do, I'm actually going to talk about an actual module that I've created for a customer. And this particular module is a PHEC temperature meter. That's what our device that we're going to use as a reference. And this is a meter that you can plug some probes into it and measure pH or EC. EC is electric conductivity. The meter is an RS-232 serial communication device. There are a number of variants of this meter. So some do 2 pH, some do 1 pH and 1 EC, and one of them just does 1 pH. And quite often my customer who uses this, he has more than one of these meters in an application. So, so what I've done is I have created a little demo project for this purpose. Let's just blank that out for a minute. Let's close up some of this. So here's my meters demo. Now, I've already created a meters module, right? This is actual code that's implemented and out in the field and working. So there's our meters module with our associated tester. There's a couple of other extra files we're using in here, and I'll quickly go through that. I've got here in my common folder a serial port class and a serial port simulator class, which is a child class of the serial port class. And I've also got some classes for the meters. And I've got a meter class, a TPS meter class, and then a number of children meter TPS meter classes that live under that, with some simulator classes that live under that. And that's basically my DQMH module that I'm going to use to demonstrate. All right, let's get on to what we want to talk about. Reason one, a DQMH module is an application in its own right. So one of the things that's really great about DQMH, you saw before when I opened up the DQMH module, it was ready to run. As soon as you've created one DQMH module in a project, you've basically created a basic application. Straight out of the box, our default module can run on its own. If we were to go ahead and create a build spec for this module, I can, I just make the tester the top level VI, and I've got an application. So if I look at, welcome. Okay, so let's look at my application. So I've got a tester. This is what my tester looks like. Now, full disclosure, my tester, not all of my testers look like this. So let me just remind you, we've got a tester, and this tester is calling my meters module. And then we've got some classes sitting underneath the meters module, and that's it. And if I wanted to, and I've done this before, I can, create an executable just from the tester, and we've got an application. So you create one module and you've got an application, which is a pretty powerful concept, I think. Let me just take you through the tester, because we're going to use this a fair bit. We have in the top left corner here, this is sort of a lot of the default stuff that comes with the DQMH module tester. We can run one or more instances. We have our default requests that come with DQMH out of the box. I've got a couple of status LEDs over here. And below that, this is the specific area. So I've gone ahead and I've created a number of, excuse me, events or requests for this specific module, right, the meter. So these are all my specific requests and the arguments associated with that, and the reply payload arguments where necessary. Over on the right, I've got a 3-page tab control. In the first page, I've got just the text box that you would normally get with your DQMH tester, right? So this is going to give us the status updated and the error reported broadcasts that come out of the module. I've added a live plots tab. In here, I am plotting data that's been broadcast from the module, right? This is to make my tester a bit more like an application, actually, make it do something useful. So I've put those in. I've only put 2 charts in here, although I can potentially fire up as many pH meters as I need. And the last tab is a subpanel. We use this a lot for a lot of the work we do, because we often will have a diagnostics page on our applications where we can insert subpanels of our device drivers, insert the front panel of our device drivers into a subpanel. So that's my tester layout. So if we run it, we're now running an application. We haven't got any modules running at the moment. I can run a new module instance, right? And in the active modules list, we have a module show up, and it's initialized. It's been initialized. We can show the front panel. All right, so here is my meter front panel. Sorry about that. Where'd it go? All right, so notice at the moment my module, it's running, but it's dormant. It's not actually doing anything. One of the things we do at WIDEIN is, the first thing we do is send down a initialize settings. request, so I can tell it at this point what type of meter it will be. So I've got a number of choices. I'm going to make it a WP80D simulator. I don't actually have the devices here with me, so I can use WP80D simulator, initialize that, show the front panel again, and now we can see that we're connected, and I'm starting to get some readings. These are simulated readings, of course, because I don't have the real device. And in my log, I'm recording everything that the module's doing, which is basically just showing you every message handling loop that got called. All right, so we're up and running, and this meter, I've got a broadcast set up. Every 2 seconds, we're sending up our reading data. So even if we don't request it explicitly from the tester, he'll send it anyway, and that's what I'm now displaying here on my live plot. So you can see I'm measuring pH 1 and pH 2 and temperature. They're just simulated. So what we have an application. So just by creating one module and using my tester to as the top level, I've got an application. So this is particularly handy for if you want to share your device driver to colleagues or customers. Like quite often my customer just wants a meters module. He doesn't want the whole application that it's normally part of, so he can just talk to meters and diagnose them or do what he needs to. So this is where this is a very valuable thing. All right. That's just some notes about what I've just been talking about. Let's get on to reason 2. Reason 2, DQMH is a great fit for creating a hardware abstraction layer. A hardware abstraction layer allows us to remove the device details from our application, resulting in our application code being a lot cleaner. For example, if you have a DMM, all the application really wants to know about is what's the voltage or what's the current. It doesn't care whether it's talking to an NI DMM or a Fluke or a Agilent. It just wants the voltage. So a HAL gives us that abstraction. Chris Roebuck, he has written a tutorial that I've pretty much followed to the letter here in this example, in this module, on how to use DQMH and set up a hardware abstraction layer. You can find on the Delacorp website, or I'll show you the link in a minute. So to create a hardware abstraction layer, what we did is, first of all, we created a number of classes. So let me just show you the class hierarchy. All right, so let me zoom in a little bit. We have a meter class, and then below that a TPS meter class, and then below that a WP80, WP80D, or a WP81 class, and then below that a simulator of each one of those. There is a chance my customer is going to need to use a different meter brand altogether, so therefore we can create another little subtree over to the side here and do something similar. So that's my class hierarchy, and as far as implementation inside our module is concerned, I just drop that out of the way. I'm going to click on the show block diagram for troubleshooting event. I didn't actually show you this code before, but we have an event handling loop, a message handling loop, and we've got a third loop in our meters module. It's a helper loop, and it's pretty simple, the helper loop. It's just keeping every 2 seconds, we're just generating a couple of elements in the message handling loop queue to periodically get status and take some measurements. Earlier you would have seen me click on the initialize settings and specify our meter type, WP80D simulator. when we look at the code for initialized settings, the meter type is coming out here. It's just an enum. I've got him wrapped up in a case statement, and depending on which meter type you select, I am just passing out the object or the class reference of that particular meter type, taking that out of here and passing it into our internal data, which is a cluster that revolves around our message handling loop. All subsequent calls to our meters class from here on in will use that class reference. So when we define at the start, this is the type we're going to use. Then from here on in, we're just using that. We're just going to override it with that class. So if I look at perform calibration, right, that VI there, that's from the meters parent class, but we're going to override it at runtime with the class that we've selected. You could extend what I'm talking about here a bit further and actually use the what they call the factory pattern. I didn't do that here. This was actually my first go at object-oriented a couple of years ago, but we could dynamically call at runtime the object we need to use. Anyway, that's so. What's the benefit of all this? Well, first of all, our application's none the wiser. If we need to add a new meter type, apart from how I've implemented it here, where yes, we still need to be able to configure the meter type through this call, this initialize settings call. That's about as much as it needs to do. As far as the DQMH module is concerned, sorry, I keep flicking between the wrong screens here. As far as the DQMH module is concerned, I'm adding a new case to here and a new class reference to here, but everything else stays the same. None of this changes, right? Because all we're doing is adding a new class to the hierarchy. Yes, I've got to go and write that new class, but the DQMH module hardly anything changes, and the application is really none the wiser. So, yeah, there's the link. I literally have followed that pretty much to the letter. So, really useful link. Thank you, Chris. All right, moving on. Reason 3, have you got more than one instance of a device? No problem, use a clonable DQMH module. So this is the clonable feature of DQMH is one of the main features that attracted me to DQMH in the first place. Prior to DQMH, I was struggling with this concept. I had simple libraries. I wasn't using classes and unable to instantiate anything. So device management, especially with multiple devices, was cumbersome at best. Then I heard about DQMH and clonables, and I thought all my prayers were answered. So one tip I've just that's come to my mind as I've been writing this presentation out is that if you're creating a device driver, lean on the side of make your device driver a clonable, because in the last couple of years, in several cases, I've started with a singleton, then realized that should have been a clonable. So start with a clonable if it's a device driver. That's my hot tip there. So just to show you in the tester. So at the moment, I've fired off one module, and he's still running. We can simply run another one, and then we have now 2 modules running. On this one, I'm gonna select the module that I've just created. I'm going to set him to a WP81 simulator, initialize that, show that front panel. So just clean up the screen a bit here. So we've got 2 modules running now. So the beauty of this, of course, is it's the one bit of code, but we just call it multiple times in runtime. So you can see this one's a WP80D simulator, this one's a WP81 simulator. All of the code under the hood, make sure you remember to make all your VIs at least shared clone reentrant. That's a tip for young players, and I got burnt by that myself only a couple of weeks ago. You can see now on my tester, we've got 2 sets of data coming in. So both of these modules are generating periodic broadcasts of the data that they're measuring. They're both simulated. And in our status, we're getting a lot of periodic status for both our modules 2 and 3 coming in. So yeah, look, clonables, it's just a really great way to be able to instantiate devices. And I mean, for this example, this is a real thing. I needed 2 to 4 meters in a project. I've had multiple syringe pumps. I've had, up to 5 barcode scanners, 2 dehumidifiers. So it's quite a common occurrence for the sort of applications we build. And so clonables is a great fit for that. I haven't been checking the chat much, but I'll keep pushing on. All right, reason 4. So I'm going to expand a little bit on, I guess, the hardware abstraction layer concept. Keep your device management hidden away. Take care of the device management in your module. I don't know if it's the same for you, but I find when I'm working with some devices, there's a lot of code that needs to sit around the device that's more specific to your application in a lot of ways. And I like to abstract that all away in my DQMH module. But there's a lot of common concepts that I'm talking about here. So one thing is, like you see that what's happening at the moment in my code that we've just been running, I've got periodic polling of the device going on. So even when the device isn't needed by my application, it's still just keeping an eye on things in the background. And because this is a serial device, we could lose the COM port at any moment, or someone pulls a USB cord out. It's pretty easy to do. So we're just, every couple of seconds, we're talking to it. We're making sure, hey, are you still there? And we can do that hidden away. So the application, knows that the device is taking care of that. Another thing is we can handle errors better internally. So once again, for a serial communication device, how often do you get a timeout error or corrupt data error or something like that, and you're trying to read from a device? We recently had a project where a device was really noisy, so we built in under the hood the ability to take a reading. If we got a certain error or a certain number of errors, those awful -107,364 blah 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 numbers, if we got one of those, we just clear it and try again. Did we get it this time? Yeah, we got the data. Okay, pass it back up. So once again, your application layer is none the wiser. You're keeping all this hidden away. It all results in a much cleaner application. Also, if we get disconnected, we can manage that a bit better. We can try and reconnect our device. So we can do a lot of stuff under the hood before we have to scream, no, I can't do this. Here's my error. Leaves you with a cleaner application. Also leaves you with a simpler interface to your device. For instance, if I go back to my tester, one of the functions I can do with this module is we can tell it to perform a calibration, right? So I've got a perform calibration button here. The interface for that from the application is pretty simple. We just basically say perform a calibration, tell it which channel, and are we doing a first point or a second point, and then under the hood, perform calibration. It's doing a couple of things, but we're doing our calibration here, and then we're obtaining GLP data in the next step. So we're able to do a couple of different. We can carry out a little sequence of events here within our module But as far as the application is concerned, he's just said perform calibration and let me know when you're done. So it just, yeah, as I said, it's a cleaner application. So yeah, reason 4 is hide away that device management. Let's have a drink of water. Reason 5. Now, you could argue this is kind of the same thing as what I've just been talking about with reason 4, but I wanted to highlight this because I thought it was quite important. We can build in some intelligence and some safety into our DQMH module. So for a recent module I developed for a customer, we had a 3-axis motion controller, and it had an X, Y, and a Z axis that it could move to. And now you couldn't just move it to anywhere. If you just went to a random location, you could do some damage, right? Because there was some measurement equipment mounted on this on the motion platform. You could easily move X and Y. That was okay, but you had to know that you're in the right spot before you moved your Z axis. So the guys that built the machine, they didn't. You could have protected all this in electrically, but they didn't. But what we were able to do is they did have some opto sensors to say whether X and Y were valid positions. So they had like an array of valid positions, right? And so when you said let's go move to X, Y, Z, we would move our motion to X and Y first, and then we would check our sensors and say, is X in position okay? Is Y in position okay? If both are yes, then we can lift our Z axis. So what we're talking about here, we're building the safety into our application. Into our device DQMH module. Once again, your application, all it needs to do in this instance is just say, move to X, Y, Z, and let me know when you're done. So we can move to X, Y, we can check we're in the right position, we move to Z, then we can say we're done. So the application, he doesn't really, need to worry about managing that. So you can pass the responsibility of that down to the DQMH module. When I talk about intelligence, I'm talking about analysing the performance of your device. I think it's a good fit for, being able to improve on that, self-tune it. It's a good platform for, Industry 4.0 concepts. But it can make decisions on behalf of the application. Another example is a syringe pump we did. The application needed to dispense 20 mils of fluid, but we've only got a 10 mil syringe. No worries. The DQMH module worked that out and said, therefore I'm going to have to dispense it, then I'm going to have to aspirate, then I'm going to have to dispense again. And once again, the application is none the wiser. So you can build a lot of intelligence and safety into your DQMH module. I've got no demo code for those takeaways, sorry. All right. So we're up to reason 6. All right, so using DQMH, you can prevent your application from being unusable if your device isn't disconnected. One of my pet peeves is when I open a simple LabVIEW application and if the device is not connected, you're affronted with an awful LabVIEW error straight away, and best you can gracefully shut your application down. At worst, it comes up with a perpetual error dialog, and you've got to go and control or kill it. That's a pet peeve of mine. But one of the things that I think a DQMH module is, it just by its nature, we can prevent that from happening. By using a DQMH module to encapsulate our device driver, we can gracefully handle those problems that we might get. Okay, we forgot to plug in a USB cord, fair enough, but we can handle that. We can let the application know about that, but not just grind to a halt. So as a demonstration, where's the tester again? I'm now going to change one of my modules here. I'm going to change my second module. I'm actually going to no longer make it a simulator. I'm actually going to make it an actual device. I don't have the device with me. I'm going to make it an invalid COM port. And I'm going to try and initialize the settings. Before I do, I'll just load him up in the sub panel here. All right, I'm going to initialize the settings. All right, so I've initialized him. I'm now getting errors from the device, and now we're getting errors coming in to our text box here. So remember, this is our tester, and in this instance is doubling as our application, right? So by loading up an instance of a module that had an invalid COM port setting, right? So our device is effectively not connected. Things haven't, grinded to a horrible, awful mess. The advantage of what we're doing here is we can now just sort of diagnose. We can have a look around. We can look at the error. We can try and work out what the problem is. What's that error? Let's copy that error code. The given session or object reference is invalid. All right, we're getting somewhere we can work out what's happening, and we can stop the module instance, and it's not the end of the world. So end result is we're resulting in a much more resilient system, and we get a much better user experience overall. Okay, a couple more to go. Reason 7, view what your DQMH module is doing in parallel to running your application. So for me, this was another important reason for me choosing DQMH. Prior to DQMH, the applications that I was writing, I found it difficult to be able to show what was happening under the hood of with regard to a device driver, at the same time that you're trying to run an automated test sequence, for instance. But now with DQMH, we can run our application and we can monitor the device at the same time. I guess in this example I've got here, we're doing it in two possible ways. The first way that we are keeping an eye on things is by being able to look at the front panel of our module, and so that tells us a bit. So it depends on how well what you end up doing with your front panel of your device driver, and whether you're going to make that a front panel that people are going to see. But quite often, like I said, for the customers we develop for, we'll have a diagnostics page where we lay out all our devices on one panel. So being able to just have this as part of the user interface is really handy. We can get a sense of what's happening with our log. And then the second thing is just using our API tester as a sniffer. Now, I mean, in this example, what we've got going on here is, my tester is my application for the purpose of this demo, but for a lot of other systems that you end up doing, your tester is going to be just a tester and not the top-level application, so you can use that to sniff things. My suggestion there is that you use the status updated broadcast within your module quite frequently so that you can get a lot more information in here about what's happening. So, yeah, look, a couple of ways to be able to actually see what's going on with your device while your application's in an automated sequence that you can't just pause or stop or run or, change. So that, for me, was a big selling point for DQMH. All right, so we got reason 8. Use templates as a common approach for your team. So With DQMH, you can save a module as a template. You can basically create a template based on your device driver and the approach that you've come up with, and share that with your team. And now everyone can write device drivers that follow your team's preferred guidelines. This is great for promoting consistency across your projects, creating a lot of familiarity amongst your team. How do we do that? If you just jump back to the tools, Delacorte, DQMH module, create DQMH module template. It fires up a little dialog. You specify the library you want to create a template from. You put a description of what this template is going to do, specify where it's going to go, hit OK. You now have created a template. The next time you then go back to your tools, Delacorte, DQMH module, add new DQMH module. The template you've created will show up in your module type list. So you can see here, device module template singleton, device module template clonable. These are our templates we've got here at Wired In for our device modules. And what you're seeing today with this example is an example of our device module template. So what we've been able to do to build into our template that is now common across our device drivers is the activity logging aspect. So we have our device drivers just logging to file, so we can find out what they're doing in the background. We've got some of them have a common front panel layout. This is for a particular customer, and that's how we did those ones, but they're not all looking like that. We add additional default request types out of the box. So that's these ones down here. We've got lock front panel controls. If I click on that, it's not actually, let's run an instance here. Lock front panel controls just locks all the controls. So when you're in an automated run, you want to be able to still go and see what's happening. You just don't want to be controlling that device. That could be dangerous. And inserting the front panel into a sub panel. So these are our default out-of-the-box requests. So when we create a template, these additional request types will be found here in the public API. Other things, we talked earlier about device connection management, error handling. We've got a few specific things we want to do, so we've built that into our device module template as well as the helper loop that I showed you, the third loop in the code, right? By default, we have a helper loop, which is pretty simple, but it's there ready to go in our template should you need it. So this is a really great reuse strategy if you're using DQMH. Use the templates. So that was reason 8, and good news, I've got a bonus reason. Reason 9 includes simulation of your device inside the DQMH module. I love this aspect of DQMH. I mean, you can put simulation into any code. It doesn't have to be DQMH, right? But the great thing about DQMH is, well, for starters, you would have seen earlier when I showed you my class hierarchy, right? We can just expand on that and add some simulator classes, right? So by taking advantage of this class hierarchy, we've added simulation in at the start there, and it's just as simple matter, like you saw from the tester, of selecting a meter type and saying you're a simulator, and away we go. We're simulating. So, so that's a really powerful concept. It's really handy for us because my client, they're on the other side of the country, and we don't have the luxury of having all the instruments sitting here while we work remotely. So what we do is we can simulate our hardware, and that allows us to concentrate on developing our application and testing our application with dummy data coming out of our simulated device. The other great advantage of this is my customer loves this because he can install his entire application on his laptop, and when he gets on the road, or if he's just doing it remotely, or he's at a conference, he can demonstrate his software that we've written for him, without sitting next to the machine. He can just set up all his devices to simulate, and he can run his software, and he loves that. He loves being able to run that and demonstrate it to people like that. So it's become a very effective sales tool in it, as it turns out. So yeah, reason 9, the bonus reason, is simulation. All right. There is my 8+1 reasons for using a DQMH module to encapsulate a device driver. So I hope you got a lot out of that, and happy to take any questions. Thank you so much for having me today. Are there any questions? Feel free to unmute or jump on the chat.
So, Chris, there were some questions I did answer to, jump to some of them. So I hope you don't mind. But if we go back, shameless plug for Tom. Tomorrow he's going to be talking about how to customize your own DQMH modules, and in his case, make it DQMH as close as possible as he could to make it actor framework. I see questions. I have them. The show diagram comes handy. Okay, if anybody wants to jump in and ask, but Matt Jacobson was asking about why encapsulating the LBOOK within the DQMH module and not just passing the DQMH as an object for your argument. So I answered that, but I would like to hear your answer too.
Sorry, which one is this one? I'm just trying to find it on the chat.
Higher up, Matt Jacobson was asking.
I can ask it again.
Yeah.
The question was basically, I'd done something similar recently, and I saw kind of two options of initializing the hardware. One was adding some input to the start method and kind of passing that in as like a front panel item for main.vi, and the other was creating an additional request for initialization. I kind of feel like I ended up doing a coin flip and deciding on start, but I was wondering kind of your thoughts on choosing one over the other.
So I'm not quite understanding. So you said you've got a start method, or you've got a reinitialize.
Yeah. So when I start the module, I basically pass it which hardware I want to use, instead of having a separate initialize method. I could see that the initialize method is nice if I wanted to, I guess, initialize it a second time with different hardware, but that kind of seems like an academic reason more than like an actual customer reason.
Yeah, that's a good point. I mean, this is, I guess, just the way we've ended up doing it, and I think I've considered what you've said as well in the past. When we launch all our modules from the top level application, or when we launch the modules that need to be launched, excuse me, basically we start the module, just like we do in the tester. Let me just bring that code up because that explains things probably easier. So this is the tester code. Where is start module? Run new module. So this is quite a common little bit of code that you would do to run your module for the first time. And typically what we would do in our applications is we would do start module followed by sync module events. And then straight after that, I'm initializing the settings. I'm calling that straight after, which, in effect is not too different to if you just did it from the start module. And I don't have an answer for which way is better. We've just done it the way we've done it, and it seems to work okay for us at the moment. So, yeah. But I have heard of others that do it the way you're suggesting. Yeah. So I'm just looking through some of the other comments here. So Chris says that was helpful. Great, thanks, Chris. Ben is asking, do you have a scripting tool that wraps a module API within a class? This will let us handle modules more easily. A scripting tool that wraps module API within a class. No, we haven't done it that way.
Benjamin, is that a question for Delacor, or is that a question for Chris Farmer presenting? Both.
Yeah. So no, I don't have a scripting tool for that. No.
Benjamin, there's an idea exchange area now in the forums. I don't know if Chris can navigate while I'm answering the question to show you that. Right now it's empty because we used to keep the requests for new features in the document comments, and that shows you my naivete of how not realizing that this was going to be this popular. And it was easy to manage for the first 3 versions of DQMH. It's becoming a little crazy now. But if you want to add the request there, I think there's already a similar feature request, but you could go and add a new one. And we definitely have talking internally about doing that, because we have wrapped DQMH modules into classes. And you can see an example of that in our blog too. I can put the link on Discord about it after presentation. But yeah, if you scroll up on the forum, Chris, and then click on Delacor Toolkits. Now you're already in the DQMH feature request. Yeah, there you go. So right now it's empty because we just literally, Chris, when was this created? Like Wednesday?
A week ago?
Yeah. But if you could show him the previous things, if you click on Delacor Toolkits and goes to the Delacor documents. Yeah.
And real slow here at the moment, but yeah.
At the top. So, but definitely, yeah, that's something that can be done. It's just a matter of, it's a free product, so we have to prioritize new features. And of course, we tend to do first the ones that we need the most. Or the DQMH trusted advisors get a higher preference on the features. So you could also bribe a DQMH trusted advisor.
Sorry, say that again.
No, I'm telling Benjamin that you as a DQMH trusted advisor get a higher priority for your requests. Yeah. They can always bribe some of the DQMH trusted advisors. Matt, is there a GitHub that you could fork? No. And the reason for that is the reason why DQMH is not open source. It is already. It doesn't take as much as technical support as I thought it was going to take, but it does take quite a few. And I realized that if we make this open source, I would still have to maintain it. So now on top of what I'm already doing, I would have to add reviewing and making sure that people that are doing pull requests are not messing up the DQMH. So at this point, I'm not willing to give up on that control. And I feel like it has been working well for everyone. So if it stops working for you guys and you think that you want it to be open source, I would have to have someone signing with their blood that they're going to take care of my baby.
Fair enough. So any other questions? I hope this was of value. So getting some good feedback there from Shane and Fab that the amount of work on it with DQMH is phenomenal.
If anybody wants to pay us to add features, of course, we will be more than happy to do that. This was excellent, Chris. It was a very good presentation.
Thank you. I feel like I need holding music or something.
Yeah, but you're right. I'm waiting. If anybody wants to unmute and ask any other questions. If not, I'll do the shameless plug too. So Tom is presenting tomorrow. We are presenting as well. We're going to be showing what's new on DQMH 5.0. So if you're already using DQMH and you're wondering why would you go through all the trouble of validating and upgrading your DQMH modules, which by the way, we upgrade for you with the scripting, come tomorrow to see that presentation. And there was another presentation, and I think Becky Linton and Chris Robock are also presenting on DQMH. And then you have an encore presentation later on the day, so he could, so Chris Farmer could have people from Asia and Australia joining.
Yeah, I'm the only one that's awake in Australia right now. No, that's not true. Douglas says he enjoyed it. Thanks, Douglas. And Jeff also. Thanks, Jeff. Thanks, Philip. Yeah, it was a lot of fun putting it together. It was stressful about a week ago because I thought, what am I going to talk about? But yeah, the last couple of days it's come together. Geez, so much time goes into these things, Fab. I don't know how you churn them out.
One thing that my blog posts have a slow down, and there's a reason for that.
That's the fourth of every element.
Thanks for your feedback, everybody. Thanks, you.
Well, people staying up late to see your presentation.
Yeah, what is it? It's probably about midnight or something, isn't it?
Yeah.
Was this recorded?
Did you press?
Do you know what? Yep, I forgot to record it.
Oh, and I forgot
right.
to record you. But you're going to have an encore presentation,
Yes.
so you can record that one.
Yep. Yeah, I'm going to be recording the second one. I'll share that with you. Sorry, I didn't record today.
It's going to be posted on your microphone or on your monitor. So
I passed the buck to you guys and said, can you guys remind me?
yeah, I was being supposed to.
You did it. Thanks, Shane. Thanks, Douglas. Thanks, Stefan. Thanks, Jörg. Thanks, Kabul. Thanks, Chris. Thanks, Benjamin. Thanks, Jesus. Yeah. I'm pretty amazed at how many people actually turned up. I didn't think I'd get this many.
You know what? I don't look at the number of people attending, but I'm sure you probably can get some report for your stuff.
Yeah, well, I saw before it was about 40 odd.
Mm-hmm.
Yeah, so.
So see, next year you come for an VIWeek.
Yeah, well, I've done the easy bit.
Oh my gosh, somebody connected from Egypt.
And Italy. Oh.
Thanks to Egypt.
And Italy.
Thanks, John.
Bonsoir.
Thanks, Benjamin. Sorry?
Bonsoir.
Bonsoir.
Good night.